Okay, let's look at the area of regular polygons. This is 9.2, area of regular polygons. We're going to focus on two types of regular polygons. One, the equilateral triangle. And if you remember, all equilateral triangles are equal angular. And so each of these is 60 degrees, each of these angles. And that's what regular is, right? Regular is equilateral and equal angular. We're also going to focus our study on regular hexagons. So a hexagon with 6 congruent sides and 6 congruent angles. But today, or for this lecture, we're going to focus on this, just the area of a regular triangle or an equilateral triangle. So let's look at an equilateral triangle. Let's say we have this equilateral triangle. And let's say that it has what we will call the apothem of 6, let's say 6 units, 6 inches, or 6 centimeters. Now, what's an apothem? Apothem is a segment that goes from the center of the figure to one of the sides, basically the distance between the center and one of the sides. And remember, distance should always be perpendicular to a side, so that's why that's perpendicular there. And so we have an apothem of 6, and let's see how that fits into our formula. The formula for the area of a regular polygon, any regular polygon, is 1/2 apothem, so we've got the apothem, times the perimeter. So we already know our apothem. Our apothem is 6. We want our perimeter. So we need to find the perimeter. So we need to find these side lengths here. Now we know this is an equilateral. We know it's an equilateral triangle. So once we find one side, we'll know each of the sides. And so how are we going to find this? If I were to draw segments from the center of my figure to each one of the vertices, I would create 3 triangles. And each one of these triangles has an angle here, a central angle. And all 3 of them should equal this full circle, or 360 degrees. So if I want each one of these angles, then I could say it should be 360 divided by 3, since there's 3 of them. 360 divided by 3 is 120. So each one of those angles is 120. So if I just pluck out this triangle, let's say I just want to take this triangle right here out, and let's look at it separate. Let's look at that triangle separate. We already know that it has an apothem of 6. And we know that each one of the angles here, or this angle right here, is 120 degrees. We just calculated that. But I have that apothem going right down the center of that. So if it's cutting that 120 degree angle in half, and let's take this arc out, then each one of those angles after it cuts it in half should be 60 degrees. And so if that's 60 and that's 90, then this should be 30 degrees. And we have a very familiar 30, 60, 90 triangle, and the short leg is 6. The short leg is 6. If the short leg is 6, and I'm looking for the long leg, I know the formula, long leg equals square root of 3 times the short leg. And I know the short leg. It's 6. So my long leg is 6 times the square root of 3. That would be this measurement here, 6 times the square root of 3. But I want the whole side. I want this, not just this. I want this whole side. So it's not just 6 times the square root of 3. The whole thing is 12 times the square root of 3. 2 times this. My whole side is, so I know this side is 12 times the square root of 3. And that means this side is 12 times the square root of 3, and this side is 12 times the square root of 3 because all the sides are equal. So my perimeter is easy to find. This perimeter is just going to be 3, the number of sides, 3 times 12 times the square root of 3. So my perimeter is going to be 3 times 12 is 36 times the square root of 3. And I'm ready to plug this all into my formula because I have the apothem and I have the perimeter. And my formula is area equals 1/2 apothem, 6, times the perimeter, 36, times the square root of 3. 1/2 of 6 is 3. And 3 times 36. 3 times 36 is 108 times the square root of 3. And that would be whatever the units are, units squared, inches squared, feet squared, whatever the units are. We didn't use a specific unit here. All right, so that's finding the area of an equilateral triangle or a regular triangle. If we have the apothem, remember we started off with the apothem. Let's try another one. This time let's start off with a side. So we have an equilateral triangle again. All 3 sides are the same, and we know the side is 8 times the square root of 3. So if we're going to use our formula, area equals 1/2 apothem times perimeter, I have something that I need there. I can easily find it. I can find the perimeter very easy because each side is 8 times the square root of 3. And so it's just 3 times 8 times the square root of 3. And that's 24 times the square root of 3. So I have my perimeter, 24 times the square root of 3. So that's good. That helps. Now, let's see. I need to find my apothem. I need A. Look at that right there. So how do I find that? Let's see. Let's separate our triangle, our equilateral triangle, into 3 congruent triangles, or 3 triangles coming off that center. Let's draw in our apothem that we're going to be looking for. It's right here. Now, if you remember from the last problem, each one of these angles here is 120 degrees. Each one of those 120 degrees. And the apothem divides it in half. So this was 60, if you remember. 60 and 90, that's 150. Minus 180 should be 30. And so I have, again, a 30, 60, 90 triangle. And let's look at that triangle separately. Let's draw that out separate. Now, I know that the whole side of the triangle is 8 times the square root of 3, the whole side, this whole side here. But I just want this side, just this part. And that's half of that whole side. So this is going to be 4 times the square root of 3. That side there. So remember, this is 60. Let's label that again. That's 30. That's the long leg, right? 4 times the square root of 3 is the long leg. I want the short leg, which is the apothem, the short leg over here. So I have the long leg. And I know that's a short leg times the square root of 3. The long leg is 4 times the square root of 3. If I want short leg by itself, I'll divide both sides by the square root of 3. And so the short leg equals square root of 3's cancel, and I'm just left with 4. And the short leg in our case is the apothem. So now I know the apothem. It's 4. And I'm ready to calculate the area of this regular figure. Area equals 1/2 apothem, 4 times perimeter, 24 times the square root of 3. 1 half of 4 is 2. 1 half of 4 is 2. And 2 times 24 is 48. And so my area is 48 times square root of 3. We'll say units squared, some kind of units. Inches, feet, yards. We didn't put any units on this one. Okay, that's finding the area of a regular triangle.